Lesson 46, finding trig functions and their reciprocals. So trig ratios they're just ratios of any two sides of a right triangle. So the trig or a trig ratio is the ratio of any two sides of a right triangle. In a right triangle, we have two legs and one hypotenuse. So depending on which leg you use, or in what order you use it, the ratio would be called certain names. So if our right angle is C, we're going to label here our hypotenuse. Now, if you, depending on what angle you are looking at, so let's say we're looking at angle A, this leg that is attached to angle A is called the side adjacent to angle A. So it's the adjacent leg. The other leg that is across from A is called the side opposite angle A. Now if you're looking at angle B, the adjacent and the opposite will be different legs. So if you're looking at angle B, the one that's attached to angle B would be adjacent, and the one across would be the one that's opposite. Heidi?
I'm sorry, but the first word is right before ratio. Does that say fried or
Trig.
What?
Trig.
Trig.
Oh, trig.
I just didn't want to write out trigonometry. I guess I could have.
Trigonometric.
So the three most common trig ratios are sine, cosine, and tangent.
How many trig ratios are there?
So we have sine spelled with an E, but when we abbreviate it, it's just S-I-N of A. So we're going to focus here on angle A. It is equal to the opposite leg, the length of the opposite leg over the length of the hypotenuse. So in our example, the sine of A would be the length of BC over the length of the hypotenuse AB. The cosine, when we shorten it to three letters, is just COS of A. So we're looking at angle A. It's going to be the leg opposite over the adjacent over the hypotenuse. Adjacent length, the adjacent side length over the hypotenuse. So that's going to be CA over AB. And it's the lengths. That's why I'm not putting little bars over them, because it's how long they are. The tangent, we shorten to TAN. And that is actually equal to the sine divided by the cosine. And if you take your sine opposite over hypotenuse and divide it by adjacent over hypotenuse, if you remember when we divide fractions, we keep it, change it to multiply, and then flip this one. So the hypotenuses will cancel, and you'll get opposite over adjacent. Yeah. So the opposite is BC and the adjacent is CA, and that would be considered our tangent ratio. Tan.
That is amazing that it's the sine over the cosine?
Yeah, you didn't know that, did you?
No, I didn't.
I did teach it to you, but I don't think
remember,
we all
but it's-
listened
we were
very
eighth
well.
It was 8th grade. We were like, yeah. They were like,
Yeah.
we were just like, yeah.
Yeah.
Great.
Okay.
Pairs.
So here is a Pythagorean triple. We are going to find the sine, cosine, and tangent of angle B. So sine is opposite over hypotenuse. We look at angle B, the leg opposite is 7, and the hypotenuse is 25. So 7/25 is the sine of angle B, and that is approximately 28/100. The cosine of B is the adjacent side to B, so 24 over the hypotenuse, and that's approximate, no, actually it's equal to 96/100. And then the tangent of B is 7/25 divided by 24/25, which is 7/24, or opposite over adjacent. That's approximately 2,916 10,000ths with the 6 has a vinculum over it. Oh, actually that would be equal to. Okay. Sine, cosine, tangent. You guys may remember SOHCAHTOA. Okay. We'll put that at the very end. So SOHCAHTOA, because you stubbed it. Epsom salts, of course. Okay, so the reciprocal
Of course.
of your tangent, no, of your trig ratios. Sorry, excuse me, I gotta get this. Trig ratios. A reciprocal is just when you take a fraction and turn it upside down. So the cosecant is, we use the CSC of A. Is just 1 over the sine of A. Or if you take the hypotenuse and divide it by the opposite leg, that would be the reciprocal. So I'm going back up to this example. Dang it, so I'm going to redraw my triangle so we don't get confused. Should have left them the same. So hypotenuse was AB, and the side opposite A was BC. And then we have the secant, which is shortened to SEC, of angle A, which is 1 over the cosine of A, which is the the hypotenuse over the adjacent side, which is AB over AC. These two tend to get me confused, and then I remember, oh yeah, they confuse me. So if it starts with a C, then it's the inverse of the sine. If it starts with an S, then it's the reciprocal of the cosine. Anyway, it's super mixed up. And then you have the cotangent. If it has the word tangent in it, then it's just the inverse of the tangent. Super awesome. Is basically the cosine over the sine, or adjacent over opposite. And in our example, that's AC over BC. Okay. Somebody wants points taken off of their score. Okay, so we're just gonna quickly run through an example. What height?
Keep it up like 10 more seconds.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yes, Tan.
Whoa. Okay, so I was looking at this,
Is that an
Two
actual
parabolas
graph like
put
this?
together.
Oh, yeah,
It's a cube.
that's looks like a sine or cosine function, depends on, is it going through the origin?
Yeah.
No, it's not just listening.
Then it's, I can't remember. I still can't remember. It's either one or the other. We will discuss that in further detail
Later.
later,
Okay.
if you can remind me, okay? Later,
Okay.
as in when we are graphing trig functions, okay? All right, so if we want to find the cosecant of b, the secant of b, and the cotangent of b. Cosecant is hypotenuse over opposite. So it's hypotenuse over opposite, which is 25/15 or 5/3. It is a ratio, so we just leave it as a fraction. The secant of b is a hypotenuse over adjacent, so 25/20, which is 5/4. And the cotangent is adjacent over opposite, so 20/15 or 4/3. That's just an example using the numbers. And is this a question that needs to be on the video?
No.
No. Okay, let me stop it then.